Okay guys, this is part 2. So on this one right here, all you got to do is, it's a right triangle. So all you got to do is use these little thingies over here. Alright, so remember theta, let's see what we have. Here's theta. We have the opposite, because remember this sidewalk doesn't touch this corner. So we have the opposite and we have the adjacent. So we're going to use and adjacent. So we're going to come over here and use tangent. So we're going to say tangent of theta equals, opposite is 6 over 8. Now you put that into your calculator. I'm going to go do it on Desmo. Okay, so since we're looking for the angle, we've got to use tangent to the -1. And then we say 6 over 8. And there it is. Again, make sure you're in degrees over here. All right, so 36.86, I'll just say 37. Okay. Oh, let me get back over there. So 37 degrees. Nope. Remember, if you're looking for the angle, you're having to do the -1. Okay. All right, so let's do this one again. Oh, snap, it's a right triangle. That makes me happy. Okay, so I am looking for, I've got 38 is my angle, and I've got the adjacent, because this guy touches the angle, and he's not the hypotenuse. Then I'm looking for the hypotenuse. So I have the angle. Check. I have adjacent. Check. And I'm looking for hypotenuse. So I'm going to come over here and use cosine. So cosine of 38 equals adjacent, which is 14.6 over x. All right, on this one right here, you'll multiply both sides by x. Equals 14.6. Then you'll divide by 38, cosine 38. All right, let's go do that on Canvas. I mean on Desmos. Okay, so when we put that in the calculator, we get 18.52. So I'm just going to say 18.5. Because they have one decimal place, so that's what I'm going to say. X equals 18.5. Good up. Let's go to the next one. All right, now on these, all this is you're just coming over here and using these little things right here. Easy breezy. All right, it wants the sine. Sine is opposite over hypotenuse. Okay, opposite over hypotenuse. So sine of theta equals opposite over hypotenuse, and then reduce it. That's it. There we go. Then we're coming over here. Cosine, same thing. Adjacent over hypotenuse. So the biggest thing is here, you've just got to know which one's the adjacent, which one's the opposite, which one's the hypotenuse, those kind of things. All right, so for cosecant, secant, and tangent, remember, cotangent, we got to remember that those are just the flips of these guys right here. That's all it is. It's just the sine is, the cosecant is the flip of the sine. See? So if that's the case, cosecant, we're going to need the hypotenuse and the opposite. So we've got the hypotenuse is 17. Cosecant theta 17 over the opposite, which is 15. And I'm done. That's it. Secant is going to be the flip of cosine. So it's hypotenuse and adjacent. So secant of theta equals, there's that. Secant, again, was hypotenuse over adjacent. 4 square root of 10 over adjacent, which is 4. Now reduce these. Square root of 10, and I'm done. Cotangent is adjacent over opposite. So cotangent of theta equals adjacent, here we go, 15, over opposite, which is 20. Reduce that. Don't forget, guys, still reducing when we have to. 3 over 4. That's it. Okie doke. Now these, same kind of thing, except this time we're doing the second sine or second cosine or whatever. So this one says find the measure of angle. Again, we're right angles, so use your right angle. Trig. So this is the opposite and the hypotenuse. So I'm going to be looking for sine of theta equals 27 over 29. So I got to go over to Desmos and do that. Let me find, oh, snap. All right, so we're saying this one again, we're looking for the angle. Don't forget, we're looking for the angle. So we're going to be doing second sine, or sine to the 1 to -1, sorry. 27 over 29. 27 divided by 29. And it's 68.59, which is 68.6. So theta equals 68.6 degrees. All right, same thing over here, except this time we're using adjacent over hypotenuse. All right? All right, now on these right here, you've got to draw it. You have to draw it. So on this one, I'm doing Sam is here, Capri is here, and they're 10 miles apart. Okay? Then they see a straight line between them. They both can see a ship on the horizon. So boop, 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 boop. The angle between the coastline and the ship for Sam, remember this is Sam. Sorry. That's 45. And then this one is Capri. And this guy, oh, wait a minute. This one's 35. Sam is 35. And Capri is 45. It looks pitiful, but it's good stuff. All right, so now I've got me a triangle that is 35 here and 45 here. We know that this is not a right triangle because we can say 45 plus 35 equals 80. And so this guy right here, 80 plus this other one, is going to equal 180. Sorry, husband's phone. Okay, and we know this guy right here is 10. So now we're going to go back over here to this and see. All right, is it a right triangle? No, it's not. So what do we have? We have two sides and we have an angle. Do we have opposite sides and angles? Well, let's go look. Well, we know this angle, but we don't know that side. We know this angle, we don't know that side. We know this side, but we don't know that angle. But can we find it? Well, yes, we can. Because if we have two angles, we can add them together and then subtract them from 180. So that equals 100. My Lanta, I cannot write. I mean, this is just sadness right here. Okay? So now, since I did that, I can use the law of sines. We're going to be looking for how far the ship from Sam. So this is Sam right here. So we're going to be looking right here, this guy. So I'm going to say side, so I'm going to say 10 over the sine of 100 equals x over the sine of 45. All right, let's solve for x. So I need to multiply both sides by the sine of 45. Remember what we did a minute ago. The 10 has to come out first. Okay, let's go to Desmos and do that. Okay, so we got 7.2. 7.2. All right, so we say 7.2 equals x. All right, the big thing with these word problems is to make sure that you are drawing them out. Okie doke. I'll try to hold office hours some. So you guys just let me know, text me back and forth. Okay? Have a good one.